Hi student, today we have to solve some MCQs of the chapter Electrostats. Let's see first problem. A network consisting 4 capacitors as shown in figure. The question is that we have to find the ratio of charges on the capacitors C2 and C4. The question is that we have to find the ratio of the charges on the capacitors C2 and C4. Now, when we observe the figure, see, here is a C4 and here is C2. But when we carefully observe, we observe that these 3 capacitors are in series combination. And hence, we first find the series combination effective capacitor CS 1 upon CS having the formula 1 upon C1 plus 1 upon C2 plus 1 upon C3. Now substitute values 1 upon C, 1 upon here 2C and here 1 upon 3C. Of course LCM is 6C, therefore here is a 6, here is a 3 and here is 2. It's the values of 1 upon CS, therefore 1 upon CS equal to 11 by 6C. And hence CS we get 6C upon 11. Okay, this is the first our work to find the CS. Now the network will become now in this way. This is a CS, this is a C4, both are connected in parallel and across them here is a cell of potential difference V. When we observe this figure and conclude that these 2 capacitors are in parallel combination and in parallel combination charges are same, potential differences across them is same, and hence we can say that Vs equal to V4. Again we know that capacitor having the general formula Q by V. From this formula we write the Vs as a Qs upon Cs. Similarly Q4 upon C4. But the question is that ratio of the charges on capacitors C2 and C4. Here C4 is here but 2 is not here, but we know that Qs now substitute as Q2 and Cs as it is. Therefore, why? Let's see, because these 3 are in series combination. Whatever may be the register charge on the third, second or first, they are always the same, and equivalent resistance charge is also same. Therefore, for the conclusion Q4 upon CS, Q4 upon C4. Now, what to find the ratio of the charge on second to the charge on the fourth? Therefore, CS upon C4. Now, CS we conclude that C upon 11 and upon C4 having the value 4, which means that 4 multiplied to 11, 6C upon 4 multiply 11 or 11 multiply 4, but the simplification divided by 2, here is a 3, here is a 2, and hence C3 upon 22. This is the ratio of the charge on fourth capacitor to the second to the charge on fourth capacitor, and in this way the correct answer is B. Got it? Okay, now new problem. Let's see another new problem. The capacitor of the capacity C has a charge Q and energy storage E. This is the first condition. What to give on one capacitor whose capacity is C, charge is Q and energy is E. Now the next condition is that if the charges is increased to 2, 3Q, let's see here 2. The sentence is 2. Okay, the sentence here is 2. Therefore, see, increase to thrice Q, and the energy stored at that time is E1. How to find the relation between this E and E1? Means E1 equal to how many times E2? E. Now, according to this first line, see, this is the first line. We know that the energy stored in a capacitor 1/2 CV square, but in this case V is not given, but instead of a V there is a Q. Therefore, by the modified formula is half Q square by C. Why? Just recall C is equal to Q by V, and therefore V is equal to Q by C. When replace and simplify, we get E, and hence this is our equation number first by the first line. Then for the next sentence, charge increased to thrice Q. Charge increased to thrice Q. Hence we can say that the new charge is equal to thrice Q. And now the new energy is equal to E1. Okay, is it clear now? Now from this condition we can say that E1 is equal to half thrice Q square upon C. By the simplification, E1 is equal to half 9 Q square by C. It means that 9 in the bracket half Q square by C. And from the first equation, the value of this as a E, and therefore 9 times E, therefore E1 is equal to 9 times E. Therefore the correct answer is D. Note down. Take some time to note down your notebook. The question is, how to initially given the capacitor having the capacitance C, charge is Q, and energy stored in it is E. By the first condition, the energy formula in the terms of Q and C as a equation 1. The next, now the charge is increased to thrice Q. Increase to, let's see, increase by and increase to. There are some difference. Increase to means take same value, that is a thrice Q. Instead of a Q, here by, then we can write Q plus thrice Q. But here is a 2, therefore directly thrice Q. Energy is E1. Again the formula is modified in this way. Here is a thrice Q bracket square, that is a 9Q square. Therefore 9 times E. This is our correct answer. Okay. Now let's see next problem. See, a series of combination of the N1 capacitors, each of the capacitive value is C1, charged by the source of the potential difference is 4Q. This is the first line. Dear student, keep in mind when we solve the MCQs, each and every word is important. Okay, therefore when we read the first line, what the first line say? There is a series combination of N1 capacitors, and each capacitor having the value C1, and across them there is a source of potential difference is 4V. Therefore by the first condition we know that suppose CS is the equivalent or equivalent capacitors of the series combination. There are the N1 capacitors and each value is C1, therefore the general formula become C1 upon N1. Got it? Let's see. When N number of the capacitor or N1 number of the capacitors of the each value C1 connected in series combination, the shortcut is CS is equal to C1 upon N1. Okay. Now potential difference across it as a 4. Suppose this Vs as a 4V. Now let's see the new line. When we read the new line, what the new line say? See, another parallel combination. Now here is a parallel combination N1, N2 capacitors of each value C2. Okay, and the potential difference across them is V. From this second line we can say that Cp is equal to N2 C2. This is a general formula when same value of the capacitors and N1 number of the capacitors connected in parallel, we get the formula. At the same time, how many Vp? Vp is given as a V. Okay. Now, third line is very, very important. Read this third line. Third line say that in this case, That is the total energy in both combination is the same. Let's see, this is important condition. The condition is that total energy stored in both combination, means in series and in parallel combination energy is same, and hence we can say that U in a series, U in parallel is a given condition. Okay, now we know the general formula of the energy is equal to 1 half CV square in the terms of V and C. Because of this, in series the formula become 1 half CS Vs square. At the same time, for the parallel combination, half Cp Vp square. In this case, of course, half cancel. Cs having the value C1 upon N1, Vs has a 4, V, but it is a bracket square, Cp N2 C2 and Vp as a V square. After simplification, we can say that C1 upon N1, here 16 V square, N2 C2 V square. Again on both sides V square cancel. But what's the question? The question is that what to find the values of C2 in the terms of C1, means what to find the values of C2. Let's see. C2 is here, therefore N2 here multiply become divide. Hence we can say that 16 C1 upon N1 N2 is equal to C2 is our correct answer. Let's see where is it is. See, the answer is here. That is the correct option is D. Okay, read carefully and observe it. Let's see. What given 3 lines. In first line, N1 capacitors having the each value C1 connected in series combination, and for this series combination the potential difference is 4V. Therefore, by the first condition, we say that series combination of the N1 capacitors of the each value C1 having the formula Cs is equal to C1 upon N1, and at the same time for this series combination potential difference is 4V. Now according to the second line, another parallel combination, N2 capacitors each of the value C2, means number of the capacitors is N2 and each value is C2 and the potential difference is V. Therefore, Cp is equal to N2 C2, Vp is a V. Now second, after the second line there is a third line, is that the total energy stored in the both combination is same. Total energy across, that is in series combination and parallel combination is same, and hence we write the condition in this way. And we know that energy having the number of formulas, but the formula in V and C as this way for the series, for the parallel half cancel, Cs substitute the values C1 upon N1, Vs 4V substitute here, Cp N2 C2 substitute here, Vp V square. Again on simplification V square cancel. What to find out the values of C2 in the terms of C1. Therefore this N2 here is a multiply, come here and become divide, and therefore we can say that our the correct answer is D. Okay. Now see, 4 identical condenser. Let's see. 4 identical condensers. That is here I want to go on the 4 condenser. Condenser means capacitor. How are they? They are identical. Connected in parallel and then connected in series. That is a 4 are having the value same. Identical means same value. First connected in parallel and then series. The ratio of the equivalent capacitance in series to that of the parallel combination is. Now in this case we can directly use a shortcut. We know that. What about the shortcut? Let's see. In parallel combination, how many capacitors? 4. How they are identical? Suppose the value is each of the capacitor and the value is C. So therefore, equivalent capacitor in parallel combination, number of the capacitors 4, each value is C. Therefore 4C. At the same time, in series combination, capacitor C, that is the capacity of the each capacitor C, and the number of capacitors is 4. That the number of the capacitors is 4. It's the general formula for parallel and series combination. Got it? Now we have to find the ratio of the equivalent capacitor in series to parallel. It means that we have to find the ratio of Cs upon Cp. Let's see, Cs, C by 4, Cp, come here, multiply 4C. Cancel, that is a 1 by 16, and therefore we can say 1:16. Read carefully. The problem is that four identical capacitors or condensers, first they are identical. Keep in mind, they are identical means each capacitor has the same value. Four capacitors first connected in parallel. We know that the general formula Cp is equal to 4C because each capacitor has the same value. Next, they are connected in series. C upon 4. 4 capacitor divided by 4. Question is that what to find the ratio of Cs to Cp. Cs, C by 4, Cp upon 4C means here multiply 4C, C cancel 1 by 16 and therefore 1:16. Now, see, next problem. Okay, see, what's the question? The potential on the plate of the capacitors are 20 volt plus and 20 volt minus. Charge on the plate is 40 coulomb. Capacity of the capacitor is. Now, when we draw the figure, this is a parallel plate capacitor. Suppose the charge on this plate is positive 20 volt. Here is a negative minus 20 volt. And the charge on the plate is Q as a 40 coulomb. And we have to find the value of the capacitor. We know that C is equal to Q by V. Q is given 40. What about the V? V is called the potential difference. And here we have to given potential on the one plate and the potential on the another plate. But what's the potential difference? Difference means subtraction. And by the mathematics we know that subtraction means larger number minus smaller number. Here is a plus 20 is a large number, minus 20 is a small number. When we taking the difference between them, that is a 20 minus 20, that is a minus 20 now become plus 20 plus 20 as a 40. Therefore we can write here 40 directly and hence C we get 1. Okay, and the unit is farad. Therefore the correct answer is B. What is important in this case? Here what is the potential on each plate? On the first place 20 plus 20 minus. Charge of course 40 coulomb. Now by the formula C is equal to Q by V because C we have to find. Q already given as a 40. What about the V? The meaning in this formula V has a potential difference and here is a potential. Therefore we take a subtraction of these two means a difference. 20 minus 20 minus become plus, that is a 40 and therefore the correct answer is 1. Okay, 1 farad. Now let's see new problem. If the charge on the parallel plate capacitor is increased by, see here, increased by, before 2 or 3 problems we say that increase to. Now here is increased by means initial plus something. Okay, now the first line is that charge on the parallel plate capacitor is increased by thrice coulomb. The energy store increased by, again energy store increased by 44%. Original charge on the capacitor will be. Now in this case suppose Q is the original charge on the capacitor. Okay, original charge on the capacitor. Therefore we know that E having the formula 1/2 Q square by C. Suppose we consider capacitor having the value C, charge is Q, energy is half Q square by 2. Now, charge is increased by 3 means Q dash in new charge, nothing but the original charge plus by plus thrice value only, not a thrice q, it is a thrice, and c is a coulomb, therefore as it is. Their energy, suppose energy, new energy, how it is? Increase by 44%, means original energy plus 44% of original energy. Let's say this is the second condition. First condition is that suppose we consider a charge q, capacity c, energy half q square by c. The condition says that charge is increased by thrice coulomb. Therefore, new charge is equal to original charge plus 3. Energy increased by 44%. Therefore, new energy original plus 44%. It means that if we solve it, new energy is equal to original energy plus 44% of original. It's written in this way by the mathematics. After the simplification, let's see, it become 144 E upon 100. That's called the E dash. Yes or no? Now, we have to now see original charge we have to find. Okay. Now, use the formula of E dash as a half Q dash square upon C. Here 144 upon 100, E as again Q square by C, and again here half. Okay, half on both sides. Therefore, these get cancelled. How many Q dash square? Q plus 3 bracket square. Here is 144 upon 100, and here is a Q square. What to find the values of Q? By this multiplication, take a square root. Here is a 12, Q and 10. Is it clear? By mathematics, how we can solve? That is a Q plus 3 equal to 1.2 Q. Now Q shift here, 3, 1.2 Q minus Q. 3 is equal to 0.2 Q. That is a 3 upon 0.2 equal to Q. Remove the decimal. After the decimal, there is a 1 digit. Therefore, it becomes 30 by 2 equal to Q. Last one answer is 15, and hence the correct answer is a 15 coulomb. Observe and note down. Here is a diagonal condition is given that the charge on the parallel plate capacitor is increased by 3, energy at the same time increased by 44. And the question is that find the original charge on the capacitor. Therefore, by the first C here, we consider C is the capacity of the capacitor, Q is the charge on it, energy half Q square by C. Now, charge increase, new charge is increased by the 3, means original charge plus 3. At the same time, the new energy is equal to original plus 44% of E. 44% of E. It means that this can be written mathematically that original energy plus 44% of E. After the simplification, we get the E dash. Now, what to do? Use the formula of E dash, half Q dash square C, E half Q square C. This as it is. By the simplification, we get this equation. We have to solve it. Take the square root on both sides. 144 the square root of 12, 100 of 10, Q as it is. Then use the mathematics. Now, from the or below this step, you can use mathematics as you wish, but the correct answer will be same. Therefore, 10 is divided, become 1.2, 1.2, Q shifted here as a minus Q. Simplify, we get the answer as a 15, and hence the correct answer is 15 coulomb. Okay, let's see another problem. See, parallel plate capacitor has a plate area A and separated by the distance small d. It is a charge to the potential difference V0 volt. The charging battery is then disconnected and plate are pulled apart 3 times the initial distance. the work done to increase the distance between the plate is. Work done means here, understand, work done means energy. Okay, work done means energy. What are we given first? Parallel plate capacitor, and we know that the parallel plate capacitor having the formula C A epsilon naught upon D. Okay, and V naught is potential difference, and hence original work done or energy is equal to half CV square, means half A epsilon naught D V square as a V naught square. This is the initial energy. Okay. Now by the second condition, distance is increased by 3 times, means new distance as a thrice D. Okay, new distance as a thrice D, and at the same time V naught as it is. Therefore, we can say new energy is equal to half CV square half C A epsilon naught, but D as a thrice, therefore here we can write thrice D and V as a V naught square, that's called the E dash. Is it clear? Now, how to find increase the distance, that is how to find the work done to increase the distance between the plate. Now work done, what to find? Now when we observe this figure, let's see, observe these options 1 2 3 4 or A B C D. What will be done now? What will we do? Okay, increase in energy means, this is called the increase in energy, means new energy minus initial, that is a final minus initial. When we substitute and observe that, here is half A epsilon naught V naught square D is common, and here 1 by 3 minus 1. Let's see. Suppose we substitute these values here, this value is here, by the simplification we get this one. There is the denominator is 1. After the cross multiplication, here we get the minus sign, here we get the minus sign, and therefore that is called the decreasing energy. Therefore, yes or no, decreasing energy. Why? Let's see. We know that E inversely proportional D, distance is increased, of course energy will be decrease. Okay, therefore after this answer, here we get minus 2 to gets cancel, 3 here, therefore answer will be A epsilon naught V naught square upon thrice D. Therefore the correct answer is this one. By the mathematics, here we get, let's see, 1 minus 3 means minus 3, 1 minus 2 divided by 3 as it is, minus 2 and these 2 cancel, here is a minus answer, but work done will be increased, means that the energy will be decreased. Okay, you understand? Now new problem, let's see the new problem. Two capacitors C1 3 micro, C2 is 2 micro, connected in series. Potential difference is 100. Ratio of the potential across C2 to C1. Now see how they are connected. They are connected in series. Connected in series. And we know that in a series combination, charge across the first equal to charge of the second. Charge of the first capacitor, charge of the second capacitor, and by this formula of the C, general formula, C is equal to Q by V, and hence we can say that Q as a CV. Therefore this is written as a C1 V1, C2 V2. C1, how many C1 is given? 3 micro, suppose the 3 micro. V1, how many V1 is given? That is V1 what to find? V1 what to find? That is a ratio of the potential difference. Okay, therefore V1 as it is. Similarly C2 is 2, V2 as it is. Therefore V1 upon V2, 2 by 3. Therefore the correct answer is A. Okay, it's a very simple problem.